Hello, this is Venkat Devraj from DataGrout.ai. We are a research lab based out of Austin, Texas, and we were spun out of an analyst firm called Select Hub. What I'm about to show you today is a demo of the DataGrout platform. And as a way for me to introduce the data platform to you, I'm going to go take you through a few slides here, then jump directly into the demo. Right here, what I would like to kind of start with is when you typically look at an enterprise AI deployment, there are some common patterns that we always see. Number one, we see that there will be some ad hoc usage through chat agents, whether it's a Slack or a Copilot or a ChatGPT, Cloud Chat. There are some agents, semi-structured agents that are connecting, whether it be for customer support or third-party partner-related agents, or other apps that kind of come in. And usually they come into a shared control plane, and there is a high code orchestrator, a low code orchestrator, different developers, different end users will kind of use, depending on their use case, they all kind of come in, flow into this control plane. And then there is an API gateway or an MCP gateway, depending on your architecture, and all your application kind of sit behind that gateway. And of course, on the other side, you have the LLMs with an AI gateway, typically throttling control, managing control with full visibility and governance happening across the stack. This is usually an architecture that seems to work well, except there are two major problems. The first one is that most of the agents, most of the ad hoc usage, all of them throw their workload directly at the LLM. And they let the LLM kind of take the task, figure it out, and whether the task be very deterministic or probabilistic, they let the LLM kind of figure it out. And the problem really stems from token usage. So when you send everything to the LLM, that burns up a lot of tokens, and essentially that increases your cost. Number two, when you give a lot of these tasks to the agent, from the agent to the LLM, there is not a lot of qualification in terms of how much data is the right amount of data. The LLM will sort through everything, it'll parse through everything, try to figure out exactly what needs to be done. But in the process, it ends up taking a lot of input tokens, and that also tends to drive up costs and drains your budget. So that's where we position DataGrout as a platform that comes in with a very innovative approach. It sits between your agents, whether they be ad hoc or semi-structured. It'll sit between your agents and your application stack and your LLMs. And essentially the way it helps is twofold. Number one, it will have a symbolic inference layer that it enables. And with this, the symbolic inference layer is built on with Prolog as a backbone. But essentially, the symbolic inference layer will ensure that anything that gets thrown to the LLM goes through DataGrout. And DataGrout will then apply its intelligence to see, is this task deterministic or is it probabilistic? If it's deterministic, it will use its Prolog engine to fulfill that task without even sending the task to the LLM. And that saves a lot of the tokens, because we find that with a lot of these enterprise workflows, it doesn't really need a whole lot of things to go to the LLM. Only things that truly require reasoning and truly require analysis get sent to the LLM. So it tends to drop down the LLM usage quite a bit, and therefore the token usage also drops down a lot. Number two, when the tasks that do need LLM access get sent to the LLM, DataGrout will look at exactly what kind of data is needed, glean the right information out of those tasks or out of those data elements, and send the right information to the LLM as a payload. So that shrinks the payload quite a bit. It shrinks the context, and you're able to find that the number of input tokens go down quite a bit. Now, enough talk. Let's see kind of how this works through some demo examples here. The first thing I'll probably show you here is this is DataGrout.ai. That's the website. I can sign in here, and you can see there are some tools here which we'll talk about. And the best way to use it is actually sign up for an account. And when you are inside DataGrout, you can click on you can create a server and you can add pretty much, any integration you want. There are really three options. One is you could use the MCP servers that ship with DataGrout to connect with your applications. Or if you already have an MCP server, set of MCP servers that you're using, you could connect them to DataGrout. DataGrout kind of sits above them, and through the DataGrout manages all those endpoints, and you expose just the DataGrout endpoint to the agent. So here's an example. The DataGrout endpoint gets exposed through MCP or through JSON RPC. So the agents can connect to DataGrout, and DataGrout behind the scene manages the various applications that you are connecting to, whether it be a Salesforce or an Altation Jira or an SAP or a QuickBooks or an ERP like Oracle Fusion. So all of that get managed behind the scenes. The third way to do it is you can actually create your own MCP servers using DataGrout. There is a tool called Toolsmith, and it allows you to craft your own MCP servers, connecting to multiple applications or from a single application with the right kind of calls, whether it be read calls, write calls. You can set up your own MCP server as you see fit. Now, once you have everything set up, once you have your agents connected, and here I have an n8n workflow. And with this n8n workflow, it's basically just connected to a very simple task. It's got an OpenAI GPT-5.6 agent connected, LLM connected. It's connected to directly through to a Salesforce MCP server. It's a native Salesforce MCP server here. You can see this one, it has 11 tools exposed. And it's also connected to the Atlassian Jira MCP server that n8n offers. So it's basically, this one is a first party MCP server, this one is a second party, and the AI agent connects to LLM OpenAI GPT-5.6. I have given it here a simple kind of relatively simple query that accesses multiple applications in the sandbox environment that we have set up. So here you can see that Salesforce is being asked what opportunities have closed in the month of May 2026. And out of those closed customer accounts, which of those have a project set up in Jira? So that's effectively, we want to make sure that any accounts that have been closed recently, we have been able to onboard that customer, get the process started, the delivery process started. So it's a very simple professional services kind of a use case. We run that query, and you can see that, it comes up with 8 Salesforce opportunities, and it kind of shows you, which ones haven't been assigned an appropriate task on the Jira side. So you see here that it's taken up 62,000 odd tokens. And that's something to note here. It's gone through all the flows, the typical flows you would expect, and about 62,000 tokens. It's connected to the Jira server and the Salesforce server a number of times, and done what exactly is needed. So that's good. Now, taking this exact same query and attaching the agent to DataGrout MCP server instead of directly to Salesforce and to Atlassian Jira, here we have taken those out of the picture, connected to the DataGrout MCP server, and DataGrout behind the scenes, as you saw, it's connected to Salesforce and Jira. So essentially, we are running the exact same query within this workflow, this n8n workflow. It runs, it comes up with the same results, the 8 accounts that have been closed, or 8 opportunities closed, 2 accounts that have been set up in Jira for onboarding, and there's 6 have not been. So when you look here, essentially that gives you an idea as to the data being the same. But if you look at the tokens here, using DataGrout, the number of tokens consumed is only 12,000 odd tokens. So on one hand, you have 62,000 tokens, and with DataGrout, the number of tokens gets shrunk to about 12,000. So that's an example of running this kind of a workflow through n8n and connecting to the exact same OpenAI OpenAI LLM model. You can see it's GPT 5.6, and everything runs exactly the same way. It's bringing up the ChatGPT model. Now, here you can see the same thing happens. Let's go to another example here. So I've got here, same, connecting to Salesforce directly, and I'm running a more data intensive query here. So the query is check in Salesforce, how many leads have come in this year, how many of them turned into a qualified lead, and what was the corresponding revenue from those leads. So pretty straightforward, but it has to go through the full half year of data. So that's quite a lot of records. So you can see the output is out here. So for this year, in my sandbox environment, I have 25,000 leads, 25,861 leads. Number of qualified leads out of those are 13,106, and the corresponding revenue shows up as 2.1 mil. Now, the number of tokens consumed is 157,602. When I run the exact same query through a modified version with DataGrout, instead of connecting directly to Salesforce and Jira and other applications, everything is managed at the DataGrout level. Single endpoint, the agent is connected there. You can see the exact same query has been given, and it comes back with the same data. Total leads, 25,000 in the sandbox environment, 13,000 qualified leads, and the corresponding revenue shows up as 2.162 mil. But here's the surprise, right? I mean, if you look at the impact here, the number of tokens, the impact is significant. So the number of tokens is really just 2,829. Compare that to 157,600 tokens versus for the exact same query, the exact same results, you see 2,800 tokens. So significant difference here. Let's move on. Let's look at a couple more examples here. So this one, here we are introducing more analysis, more math, and we will kind of, we are progressing the complexity of the query. So check in Salesforce, how many leads have come in, and which day of the week, is it Monday, Tuesday, Wednesday, when lead volume is the highest, and which day is the revenue highest from those qualified leads. So again, this one runs without a DataGrout. It's directly connecting to the Salesforce native MCP server. And you can see there are 25,000 leads, 4,900, and highest lead volume is on Wednesday, it shows, and the highest HQ revenue is on Friday, which incidentally, this data, when you verify, this is not accurate. So we found that the highest lead volume was on Tuesday and the highest HQ revenue was on Thursday. So when we manually did the verification in the Salesforce sandbox environment, so the data gets misreported. And it's doing that with a lot of confidence and showing it as though it's all accurate. But the reality is it's off by a day on both fronts. And then if you look at the tokens, it's 160,000 tokens. It's used up to run this using GPT-5.6 Luna. And then here, we got the exact same workflow connected to DataGrout. And we run the exact same query right here. How many leads in Salesforce this year? Which day is the highest lead volume? Which day is the highest revenue from those qualified leads? And it runs with 18,000 tokens instead of the number of tokens here, 160,000 tokens. That shrinks to 18,000. But equally importantly, or I would say more importantly, the quality of the answer. It's actually accurate here. So it shows this year, we have had 25,800 leads come into the sandbox. Of that, Tuesday is the highest lead volume day, and then Thursday is the highest revenue day. So it shows those details accurately going through DataGrout. And one of the things we noticed here is that when we run the agent directly through Salesforce's native MCP server, the data, the reason it's off by a day, it's using UTC timestamp for figuring out the leads and the revenue. So it's showing Wednesday and Friday, whereas through DataGrout, it's inheriting the current user's policy. When they have set it up, it's using that, the timestamp is different. So it's showing the data that's to be expected, the more accurate data. So you can see that DataGrout intelligently manages that and gives you back the data at the right level for the user that's running this. So worth noting that. And then a couple more use cases as we kind of increase the complexity. Going back to the original AI agent workflow, it's connected to Salesforce native again. And here we are saying, using the last 6 months of Salesforce leads, build a quality score for each lead source that combines conversion rate, speed to convert, and company size of the leads. Normalize everything so the factors are comparable. penalize sources with small sample sizes, identify statistical outliers, give me the final ranking and the numbers behind it. So you can see here with DataGrout, one of the things is when it comes across these kind of opportunities, right? Whether it's a lot of data, it will use certain tools to shrink the data. So like Prism and data manipulation tools that it has at the symbolic inference layer. So the context is not bloated, the context is shrunk. But also when it comes to math, it has its own math engine built on Prolog. So it's able to kind of, run through those kind of deterministic operations without sending that to the LLM. And all of us know, depending on the LLM model, right, the math is not necessarily its strong point. It's changing, but nevertheless, the data, the results can be very kind of subjective. Let me put it that way. So one of the things, when I see that, right, that is happening. So we got this use case that uses a lot of data, 6 months of data. It runs through statistical analysis. And when I connect that directly to Salesforce's native server, it uses over 2 million tokens. And then it comes back and says, hey, no valid final ranking can be produced from the current Salesforce data. So it went through the data, it looked at the number of leads, but it's checking the is converted flag to see if those are the conversion, the quality scores. It's using the conversion rate from the is converted flag. And here in the sandbox, we have a custom Salesforce schema. So we use the lead status as the conversion mechanism to kind of, track, what is converted, what lead is converted into a qualified lead, and so on from a revenue pipeline perspective. So it's using the default schema. It's saying that, hey, no valid final ranking can be produced. And it's used up more than 2 million tokens just to tell me that, which is disappointing. Now, using DataGrout, connecting the workflow to DataGrout's MCP server, run the exact same workflow here using the last 6 months of Salesforce lead, build a quality score, and normalize everything so the factors are comparable. And this one has used 22,771 tokens. So you have 2 million plus tokens on one hand, and the data is not conclusive. Whereas here, it's 22,000 tokens. And you can see that over the last 6 months, DataGrout comes back with the right data. It has fed the right information to the LLM. The LLM does its job, comes up with the data. DataGrout will then apply its math functions at the inference layer and come up with all the statistics, the conversion rate, the speed to convert, and it comes up with details in terms of exactly all the information that is needed. So again, you see the output is more deterministic, it's more reliable, and the token consumption is much, much lower than what you normally see. So just wanted to kind of share some of these stats, some of these demos with you. Happy to also, I realize all of these are happening on n8n. We can also, in a subsequent session, we can run similar kind of use cases on Claude. And so the two takeaways I want to kind of share with you is, number one, reducing the number of calls that go to the LLM. That DataGrout handles that by design through its symbolic inference layer. And at runtime, it figures out what needs to go to the LLM versus not. And then number two, the context optimization capability using things like refract and math and other functions. It's able to send just the right information to the LLM, reducing the number of token usage significantly and reducing the cost. So really, I mean, when you look at the end result here, there is a question that often comes up, like, where does DataGrout often sit? So when you look at a typical enterprise AI deployment, right, I mean, you have your end user layer, you have your planning and orchestration layer, you have your execution layer. So typically we see DataGrout sitting right at the integration layer, just alongside the various API gateways. If you already have an API gateway, you can continue using that. You do not need to change your topology. So DataGrout sits just above the API gateway. It will kind of take all the input calls from the various agents. It will then decide what application needs to talk to, what's the right tool call it needs to surface, send that to the API gateway, and the API gateway will then do the final connection. Same thing with the LLM. DataGrout will decide what call needs to go to the LLM, and accordingly, it will then send it through your model gateway to the approved model. And everything happens just like you have set it up with the governance layer, the logging, the tracing. So you have that full visibility. You can also go into DataGrout and see exactly what the runs produced. So you can go to the runs, and there is a full information in terms of what ran, when it ran, and there is a CTC, a cognitive trust certificate, that tells you how many, what kind of calls were used, what exactly ran, how many credits, DataGrout credits were used up. And in this example, there are 3 credits used, and the budgeting was initially estimated at 3, and then accordingly it will show you exactly what was done with cryptographic proof. So all of that information is available in DataGrout. So going back to your planning layer, right? I mean, all of that can happen as you have set up, and then you can see that logging and the tracing and make sure everything happens fine. Now, for organizations that require a more self-hosted type of environment, DataGrout does offer that. So if a multi-tenancy public cloud infrastructure is not helpful to you, if you need to bring DataGrout as a fully hardened appliance, you can do that. You can run it inside your firewall, and we support that. And if you, like I said earlier, if you have already, if you don't have a API gateway or an AI gateway, you can set up DataGrout to use some of the additional functionality. Or if you have something like Amazon Bedrock that you've already set up that gets you access to the approved models behind the scenes, or you have a Kong API AI gateway, you can continue using those and just use DataGrout to kind of optimize the token consumption for you. So that's in a nutshell what DataGrout is. We are happy to also accept any pilot requests. If this is the kind of functionality you would like to try out in your organization, please let us know. Please reach out to pilot-request @DataGrout.ai. We're accepting applications right now, and our professional services team will work with you. And I highly encourage you to work with our professional services team. Of course, you can go to DataGrout.ai, set up a free account and play with it. But from my experience, right, I mean, when you look at like a proper rollout, there are some things you need to do on the DataGrout side to set things up to ensure your agent is using DataGrout optimally. Depending on the agent, depending on what level of usage you have, the agent may sometimes bypass DataGrout because it thinks that the agent can directly connect to the applications and get the information it needs. So to try to bypass it. So in some cases, you almost have to kind of tell the agent, hey, use DataGrout for all of your application connections. Here's an example. For some of the examples I was showing you just now, connecting to Salesforce, connecting to Jira, connecting to pretty much any application, you can kind of tell the agent exactly what needs to be done. Our professional services team is really good at setting it all up for you. So if this is something you would like to test out and pilot in your environment and enjoy the token savings benefit, enjoy the context reduction benefits, please reach out, and happy to work with you. And we can target 1 or 2 or 3 example workflows that would benefit from a pilot scenario. And we can certainly meet up and chat through it and do some benchmarking to make sure you're seeing significant savings on the tokens. So thank you very much. Appreciate your time. Appreciate you guys watching this. If you have any questions, please reach out. Thanks again.